Welcome to my channel. Today we're looking at how to evaluate definite integrals by substitution, and we'll have to borrow a lot from our previous videos, for instance, where we used to integrate mentally, where we can integrate mentally between that, and I've already shown that in my previous videos. Now, so we want to look at several examples, as usual, just to ensure that you grasp the concept. So when we talk of definite integrals, then we mean those are integrals where you have limits that we are integrating from one point to the other point. So this is the lower limit and this is the upper limit. So basically we already know how to integrate. So the only thing we are doing the only new thing is now how to bring in the integrals. But we've already shown in our previous videos how to integrate by substitution. So let's just go to our workings so that we see what we did, what I had already done. But we already know how to integrate. So there are very many good questions here, and we want to see how to approach them, especially in the time when we are dealing with the limits. For instance, I want you to take note from the very beginning that this is integrating a trigonometric function here, and look at the limits here. They're not the same as the limits we have in part C. So we'll be seeing how to treat these two because the way they're integrated is different. The limits here are different from the limits here because these are just numbers 1 and 2, and these are angles. And look at this one. This is also an angle, and this one is just numbers. So I've put these two examples, C and E, to show you how to integrate when our limits are numbers, and B and D will be helping you to see how to integrate when the limits are angles. And then, of course, I have these G and F again, just to help you know how to integrate when I have a root in the denominator, and again this. And of course, just using substitution the same way we've done before. So let's go to our first example. The solution is here. So this is what we want to integrate, and we say that we would let this be u. So let u be 10x minus 2, and then differentiate on both sides. When you do that, you get that on this side you have du, and this other side you have 10 dx. That's what I have. And then make dx the subject of the formula by dividing both sides by 10. When you do that, you get that dx will be du out of 10. We are now ready to integrate by substitution. So our integral from 1 to 3 of 10x minus 2 raised to 3 can be written as this. Instead of this, I have u, then raise it to 3. Instead of dx, I have du out of 10. Then take the constant outside the integral sign. And the constant here is 1 out of 10. So 1 out of 10, the integral from 1 to 3 of u cubed du. Now, the integral of this, you know it, that we add 1 to the power and divide by the new power. So this is what I have, 1 out of 10. The integral of this is u raised to 4, then divided by 4, then plus constant of integration. So this is the same as u raised to 4 over 40 plus c. Now, since we are doing definite integrals, this is not very important. You can do away with it. You can do without this constant of integration because, of course, we'll be subtracting. So when you add it here, it will be c minus c and it will be 0. So it's needless putting it here. But I've just put it because we know that whenever we integrate with other constant, there will be time we say that it's not useful. Now, so we cannot substitute our limits at this point because we have u which was not in the question. These limits are for the value x, the variable x, not for the variable u. So that means that you must bring back your u. Your u was 10x. So that's what I did. 1 out of 40 into bracket 10x plus no minus 2 raised to 4. The limits are from 1 to 3. Then it's now time for us to put our limits. We are now putting our limits. But this is very important that you don't reach here and put the limits that is say this is 3 raised to 4 number. You have to first of all bring back, get rid of u, substitute the u back with its equivalent. And the equivalent of u, again, we said at the beginning that u was equal to 10x minus 2. So you must bring it back. Now let's put the upper limit. That's 1 out of 40. 10, instead of x, put the upper limit 3 minus 2, then raised to 4. And then this time, put the lower limit 1 out of 40. 10 times the lower limit minus 2 raised to 4. When you do with your calculator, this will be it. Alternatively, instead of expanding that, you just have said 1 out of 40, then open bracket and say 10 times the upper limit, which is 3, then minus 2, then this is you raise it to 4, then now minus, again it's 10 times the lower limit, which is 1, then minus 2, raise it to 4, then close the bracket. So that this is 28 raised to 4. 1 out of 40. This is 28 raised to 4. And this is 8. 8 raised to, this is raised to 4. 8 raised to 4. And when you do this, you calculate, you get 15,260 as the answer. Let's take the next example. The next example, we are integrating a trigonometric function, and it's good to note the limits are this pi from 0 to pi out of 2. These are angles. So to do this again, we just integrate the same way we did. And you see this one, to integrate this one, we say we can do it mentally. Although I've done it using the other method, but we know we can do this. The integral, we said that the integral of a cos of bx dx can be written as a out of b sine of bx plus cos of integration. Well, that means that the integral of this will be 7 out of 5 sine of 5x. Sine of 5x. Now, because we are doing it, it's a definite integral. There's no need of the constant. So we say from 0 to pi out of 2. Pi out of 2. And that's what we see here. That's what you see here. That's what you're seeing. 7 out of 5 sine of 5x, then we are doing from 0 to pi out of 2. So you can see, if you're doing it mentally, it becomes very easy. But if you want, you can use these other steps, like this from here, with these other steps, and come all the way up to here. But one can do this question in 2 steps. But I had already shown you that. Now, so it's now time to put our limits. because we've already found that the integral is 7 out of 5 sine of 5x from 0 to pi out of 2. So let's put pi out of 2. So that is 7 out of 5 into sine of 5 times pi out of 2 minus sine of 5 times 0, which is the sine of 0. Now, so what is sine of 5 times pi? You know that pi in angles, pi is 180. Pi is 180 degrees. So what I'm talking about is sine of 5 times 90, because pi over 2 is 90. So sine of that is the same as positive 1. What about sine of 0? Sine of 0, of course, is 0. So what we have here is 1 minus 0, which is 1. And so 1 times 7 out of 5, the answer is 7 out of 5, which you can also write as 1. I want to take the root of doing this method because we are able to do it and often reduce on the markings. Let me look at the next example. The next example, this one I'm integrating. And it's very important that these are not angles. This is 1 to 2. These are not angles. So you want to see how I did it. But now to integrate is very easy now to do it. We know that if you put 12 out of 7, sine, the integral of course is sine 7x. So you can see if you're doing it mentally, it becomes just one step. Just one step thing. Now, so we have our limits from 1 to 2, and we note that they are not angles, and we also note that trigonometric functions are supposed to be expressed in radians. They're supposed to be in radians. So if I were to put the limits, these are limits, this is what I would have. I would have 12 out of 7 into sine 14 minus sine 7. But since these are not angles, when I talk of sine 14, what do I mean? I mean, when I talk of sine 14, what I mean is that the sine of 14 radians. This is sine of sine 14 is the same as sine 14 radian. The same as sine 14 radian. What we know is that 1 radian is the same as 180 out of pi. Is 180 out of pi. So when I talk of 14 radians, I mean 14 times 180 out of pi. Because this is 1 radian, this is 1 radian. So 14 radians is 14 times that. So that's why you see, if I were to put this constant, this is what I would have. But this, to me, I read it as sine of 14 radians minus sine of 7 radians. And that's what I got here. That is 12 out of 7 into sine of 14 radians minus sine of 7 radians. But I've just said what a radian is. 14 radians is this. 14 times 180 out of pi minus 7 radians. 7 radians. 7 times 180 out of pi. Now this you can now do it with your calculator. And pi, this pi is the pi of 3.14 something. 3.14 something. But it's also in your calculator. It's also in your calculator. For instance, on my calculator, when I press shift, I can see there's a pi something. It's that pi. and I press shift and press pi, pi comes like that. And if I say then equals that, that pi gives me something like 3.14159 and so on. So that's the pi that I'm using. That's the pi that I'm using. So when you use your calculator here, 12 times whatever is here, of course this will be, what is this? 14 times 14 radians. 14 radians is 14 times 180 divided by pi. And that gives me, is a minute? Yes, 14, sine of 14 radians. It was supposed to be sine of 14 radians. So what is the sine of that? Sine of that, I'm getting 0.990607 and so on. What about this other one? This other one is sine of 7 radians. Sine of 7 times 180 divided by pi. And that is giving me 0.6. 0.6589. So what I'm doing this so that when you confirm your calculator and see whether you're getting the same things. So when I subtract these two answers and multiply 12 out of 7, this is what I get, approximately this. If I were to write it to 5 decimal places, this is what I get. So I've just explained what I mean by those radians at this point, and I'm just saying that trigonometric functions will always be expressed in radians, so that when on top of 14 sine 14, this makes the sine of 14 radians. It's the sine of this. The sine of it. It's supposed to be sine. Supposed to be sine. Sine of this. Sine of this. Which is now, so again, I go back to these other examples. They are just to make you again familiar with this type of questions. And I want to integrate with this. I can see the coefficient of x is 4, so that my integral will be 4 out of 9, no, 9 out of 4. And the integral of sine, of course, is a negative cos. And then I just put 4x plus pi out of 3. Now, that is not done. We've already integrated this, and so we want the limits to run from 0 to pi out of 4. To pi out of 4. 0 to pi out of 4. Let's begin by, let me first of all write it as negative 9 out of 4, and open this larger brackets. Cos, instead of x, I have pi over 4. So what is 4x? 4x is 4 times pi out of 4, which is pi. Plus pi out of 3. And then minus cos, and then at this point, I'm now putting the lower limit, which is 0, instead of x. So this will be 4 times 0, which is 0. Then plus pi out of 3, and that's what we get. Then close the bracket. Now, what is pi plus pi over 3? This is the mass 4 pi over 3. This is mass 4 pi over 3. Let me just write it as 4 pi over 3. So here is the mass 4 pi over 3. Just add. Now, so what is cos of 4 pi? And remember that pi is 180. It's an angle this time. Pi is an angle. So cos of 4 pi, that is 4 times 180 divided by 3. And that gives me negative 0.5. That gives me negative 0.5. So I have negative 9 out of 4 into negative 0.5. And what about this other one? Cos of this is same as 180 divided by 3, which is 6. What about cos of 60? Cos of 60. And again, that one is positive 0.5. But there's a negative here, so negative 0.5. So this is negative 1. Negative 1 times negative 9 over 4 gives me positive 9 over 4, which you can also write as 2.25. What about this other example? And again, we are doing it, we are avoiding so many steps as we do this. So when we do this, we remember that the coefficient of x is 9, and we have these 2, so it will be 2 out of 9, and then the sign, the integral of the negative cos, and then put this 9x plus 7. Then if it were indefinite integral, would have added constant integration, but this is a definite integral, so there's no need of that constant integration. So this is what I got. Then this time again, remember that the limits are not angles, 0 to 1. So when I put 1 at this point, I would have 9x plus 9 times 1 plus 7, which is 16. And when I put 0, I would have 7. And I have to recall that this means the cosine of 16 radians. The cosine of 16 radians, which is same as 16 times 180 over pi. Cos 16 over 180, no, cos 16 times 180 over pi. And this other one is cos 7 times 180 over pi. Now, when you do this with your calculator, this is what you arrive at. That's what you arrive at. Of course, after multiplying that by negative 2 out of 9. Let's look at this other question. Again, this you can do it mentally. Of course, I can see the coefficient of t here is 3, so that the integral will be this constant over this constant, 5 out of 3, and the rest remains e3 raised to t plus 7. Then from 0 to 1. This one you can just put, let's put the upper limit. So of course it's 5 out of 3 into e raised to 3 t plus 7. The constants from 0 to 1. So when I put the upper limit, this would be 3 times 1, which is 3, plus 7, that is 10. And when I put the lower limit, this would be 0 plus 7, which is 7. And so this you can do, this one is on your calculator. You can do it with the calculator to get this. And I've given the answer to 3 decimal places. And the other good questions here. So let's look at these good questions. We integrating from 4 to 1. and what you're indicating 7s over the root of 13s square minus 2. So this again we must let whatever is under the root to be u. So let u be 13 times s square minus 2 and differentiate both sides. When you differentiate both sides, the left side gives you du and the right side gives me 26s ds. And make the s the subject. Make the s the subject of the formula by dividing both sides by 26s. So when you divide both sides by 26s, you find that the s equals the u out of 26. The u out of 26. So let's now come back to our integral, just to substitute these values. So with the integral from 4 to 1, this is what you have been given. So I just want to substitute this for what we have. This, the denominator under the root is u. We call it u at this point. And the ds, we call it du over 26. Yes. Du over 26. So at this point, s will cancel the other s. And we take the constant outside. So when you take the constant outside, the constant is 7 out of 26. The integral of 1 over root u du. This is the same as this. This is the same as this. So bring back s. Because our u was 13 s square minus 2. So substitute back. So when you substitute back, just get space and do that. When you substitute back here, what you'll have is 7 out of 13. Instead of this u, and remember it's raised to a half, which means squared. So instead of u, we have the equivalent of u, which is 13s square minus 2. This is what I have here. I just took this off the numerator. It's already in the numerator, but I think so I just took it 7 times 13s square minus 2 divided by 13. Yeah, that's what I have. The limits are from 4 to 1. So when I put the upper limit, which is 1, this will be 7 in times, this will be 13, 1 square is 1. So 13 minus 2 will be under the square root. That's what you see. Now put the upper limit, which is 4, 16 times 13 minus 2. I have 2 or 6 under the root. Then divide by 13. And that can be done with your calculator. You get negative 5.9425. My answer is given to 4 decimal places. Now the last question, let's look at the last question. Just the same reasoning that I let whatever is under the root be equal to u. So let u be whatever is under the root. And differentiate both sides to get du equals to 21x squared dx. And divide by 21x squared on both sides to make the x the subject. So what you have is that the x will be du out of 21x squared. Once that is done, you go back to your integral and just do the integration from 0 to 2 of this. Substitute. Where there is this 7x cubed plus 2, what is equivalent, which is u. So under the root we have u. And the dx, we have this. So you write where there is dx, write this. And x squared will cancel with this x squared. So that our constant that we're taking after the integral sign will be 1 out of 21. And so what we have, at this point, when I take the constant outside, I have 1 out of 21. The integral of, no, from 0 to 2 of, this is u raised to a half. Du. That's what I wrote here. Now integrate this. Just add 1 to the power. And what I have will be a half plus 1 divided by the new power, which is, of course, 3 out of 2. A half plus 1 is 3 out of 2. And just substitute by 3 out of 2. So this is 3 out of 2. And I have 1 out of 21 here. And we are doing it from 0 to 2. So when I divide by this, and you know that this, in fact, if I were to do it in a simple way, this is just 1 out of 21. U raised to 3 out of 2 divided by 3 out of 2. And you know that when I say divide by 3 out of 2, it's the same as saying times 2 out of 3. So this will turn to times 2 out of 2. It will turn to times 2 times 2 out of 2. So you can now see how I got 2 out of 63. You can now see that 3 times 21 is 63 and 2 times 1 is 5. And this remains. This one I have to, this I have to bring back the u. Our u was that. Our u was that. So let me just write that again. Just write that. So what we have? We had 2 out of 63, u raised to 3 out of 2, and we are doing from 0 to 2. So I just brought back this. Just brought back that, and I have 2 out of 63, and instead of u, I have 7x cubed plus 2. Remember, it's in the numerator, and then 1 raised to 3 out of 2. So this one I just wrote as, this means square root, and this one means cube root. Cube by the power. So this is same as 2 out of 3, 7x cubed plus 2 cubed. But then the square root of that. So that's what you see. That's what you see. Square root because of power 1 over 2. And the cube because it's raised to 3. So this is what you see. Now I'm now ready to insert the limits. I'm now ready to insert back the limits. Let me just do what I did. So when I erase that, insert the limits. So when you insert the limits, when you insert 2, this will be 2 raised to 3, which is 8 times 7, which is 56, plus 2, which is 8 cubed. What about this other part? When I now insert the lower limit, I would have 7 times 0 cubed, which is 0, plus 2. So cubed. And so when you use your calculator, you arrive at this as the answer. And so that is how we do these definite integrals.